Slide this simple paper sleeve up, and you instantly have a working beam of light. By combining a few basic household materials, you are going to build a functional tool from scratch and see exactly how an electrical circuit operates. You'll need 2 AA batteries, aluminum foil, some cardstock, tape, a rubber band, a strip of thin foam, and one very specific component, a bulb clipped from a string of Christmas lights, with the ends of its copper wire stripped bare. Because we are working directly with exposed metal that conducts electricity, you must wash your hands thoroughly as soon as we finish this build. Step 1 is building our power source. Take your 2 AA batteries and tape them together end to end. Look at the flat ends of the batteries. The positive end of the first battery needs to press directly against the negative end of the second battery to allow electricity to flow. Wrap the tape tight enough to hold them, but keep the tape completely off the metal contact points at the top and bottom. If tape gets between those 2 touching ends, it will block the current entirely. Now, take the stripped copper wire attached to your bulb and tape it firmly to one end of your new battery pack. It doesn't matter which end you choose. Make sure the bare copper is pressed firmly against the metal center of the battery. Copper is a highly effective conductor, meaning it will carry the electricity out of the battery and up to the bulb. Next, fold a piece of your aluminum foil into a strip about ½ an inch wide. Tape this strip to the completely opposite end of the battery pack. Then, wrap your rubber band tightly around the whole assembly from top to bottom to hold everything in place. This illustrates a short circuit. If your exposed wire and foil strip touch directly, electricity bypasses the bulb and flows terminal to terminal. This rapid heat buildup will drain and ruin your batteries. Keep them separated. Let's build the casing. Wrap your battery pack in the thin foam strip until it is just over 1 inch thick, and tape the foam so it doesn't unroll. Take your large piece of cardstock, roll it into a cylinder, and tape it shut. This is the main body of your flashlight. This diagram shows exactly how our pink foam-wrapped battery pack aligns with the brown cardstock tube. Following that layout, push your battery pack firmly into the cylinder. Make sure the light bulb, copper wire, and foil strip all stick out of the top. Double-check that your exposed copper wire and the foil strip are sitting safely away from each other at the top of the tube. The internal foam serves a structural purpose. It locks the battery pack in place to prevent the fragile electrical connections from shifting or failing as you use the flashlight. Take the foil strip sticking out of the top, fold it tightly over the edge of the tube, and tape it flat against the outside. Leave a section of the foil completely exposed. Take the remaining copper wire, fold it over the opposite side of the tube, and tape it down. Leave a patch of the bare copper exposed here too. Patiently, check one more time. There must be a clear physical gap between the foil and the wire on the outside of your tube. Now we build the switch. Take your small piece of cardstock and wrap your remaining piece of foil around it, taping it in place. Wrap this foil-covered cardstock around your main tube, with the foil facing inward. Tape the outside of the cardstock to itself to create a sleeve that is snug but loose enough to slide freely up and down the main tube. This sliding sleeve is your mechanical switch. When you move it, the foil on the inside will bridge the gap between the wire and the foil mounted on the tube, safely connecting our 2 conductors on demand. Let's test the circuit. Slide the outer sleeve up until you feel it press against both the exposed copper wire and the folded foil at the top of the tube. As soon as the internal foil touches both points, the loop is closed and the bulb lights up. Slide the sleeve back down, the physical connection breaks, the electrons stop flowing, and the light shuts off. If you are using an older incandescent bulb, it glows due to a property called resistance. The tiny filament inside the bulb fights the electrical flow passing through it. That friction generates intense heat, which makes the filament glow brightly. You have successfully engineered a controlled energy system. If your light is shining, look around the room. Find a classmate whose circuit isn't working yet, and use what you've learned to help them troubleshoot their build.